I'm Ashutosh, AVP Growth and Marketing at edForce. Thank you for joining our edTalk, Next Gen Mobility, a complete guide to EV technology. In the next 2 hours, we will cut through the buzzwords, focus on teams, what focus on what teams can use on the job. EV architecture, end-to-end, BMS, HV safety, charging standards. And what's next for the connectivity with V2G. This session is recorded. Link will go to all the registrants. Post your questions in chat. We will address them in between or in Q&A. Giveaway for those who stay till the end. Keep motivating us with a lot of emojis throughout the talk. From the shop floor troubleshooting to boardroom readiness, Lalit Goyal has trained 10,000 plus professionals, earning TUV SUD's Best Trainer EV Award in 2024 and 2025. A guest lecturer globally at a lot of renowned top B schools. And yes, there's much more about him. I won't steal the thunder. Lalit will share the rest himself. Thanks, Lalit. Let's dive in straight, starting with EV system, view, and how all the blocks connect. Once again, great to have you with us. The screen is all yours.
Thanks a lot for that lovely words, Asutosh. So just a small introduction, guys, before I start. So let me share a bit about me before I start, right? Just a moment. So how many of you have a basic understanding of electric vehicles before we start? Yeah. Yeah. How many of you? Okay. So let me start with a very small introduction about me. So today, if you want to know the meaning of anything, what do you do? Google, right? So when you do the meaning of Lalit, it comes out beautiful. Now it's up to you to decide I'm beautiful or not. Huh? So Lalit is for beautiful and Goel is from business community. So we believe in transaction, right? Agarwal community. So I've worked with a lot of organizations starting from Mahindra and Mahindra, Skoda, Tata Motors, CNH. So then Maruti, and Maruti is, working for them last, starting their WagonR project in the 2015. And here 2025 launching their e-Vitara. So a lot of things have worked out. Then I'm part of the charging infrastructure for Siemens, Bosch. There is a car. There is no car made in the world without a single part of Bosch. So something of Bosch is in every car. So I'm also part of Bosch, right? Then Eaton. Then I'm part of a lot of Government of India policies and framework. I've done right from Home Ministry, Supreme Court, everywhere, globally helping the working team to understand the EV infrastructure, create policies regarding them. Then BHEL, all the government PSUs, part of Bosch USA, Bajaj Auto, MSME. Then also, not only you, but I'm also helping the chief secretaries of the state government, central governments, and the ministers, right? Then helping a lot of college, university students because they are the future. Then I'm brand ambassador for India. That means I take this knowledge on behalf of Government of India to Commonwealth countries, supporting number of startups here, right? So let's start. So Lakshya has something to say. Yeah, Lakshya, go ahead. Lakshya, I just saw your hand raise.
I think that was a long time ago.
Okay.
Everyone who has anything to share, please put it on the chat box.
Okay. So let's start with what is electric vehicle. So how many of you know what electric vehicle is? Because today a lot of myths will go away. You all have learned. जहाँ रोशनी होती है वहां अंधकार नहीं होता, right? So when you have the right knowledge, all the myths are gone. So anyone want to share something on electric vehicle can go ahead. So let's start with the subject, right? So we'll start with a basic introduction of e-mobility, which is a bigger picture. Because if you have to swim across a sea, you know the depth and the length of the sea, right? So we'll start with the e-mobility. We will start with the electric vehicle. And let me tell you, this will be a game changer. Okay. So let's start. Now, we all know electricity, right? Every day, a lot of work made easy because of electricity. So, have any one of you tested electricity? That means you have come in contact with electricity. Yeah. Hmm? By mistake. Okay. Anyway, you know, okay. Good. Electricity is the best teacher in the world. You touch it, it teaches you. But do you know how much is high voltage and how much is low voltage? Low voltage means till that voltage you touch electricity, you are here. And high voltage means you touch and you are 100% stress free. Stress free in 2 milliseconds for life. That means, so these vehicles come with these two categories we'll start with. But before that, let's take a simple question. Define the e-mobility. Okay. So we generate electricity, right? Huh? I hope everyone is clear. We generate electricity, yes or no? Excellent, Smriti, excellent, Prakash, excellent both. Yeah. Okay, edTalk says no, huh? You know the answer, right? We all have studied in class 9th. We all had science, right? In class 9th. After 10th, we all got the different subjects and we just bring that professional part. Before that, in class 9th, there was a science book, chapter 6, energy. Remember what it said? Energy can't be created and not be. Remember? Oh, Lakshay, very good. Excellent. Right? Smriti, excellent. Yeah. So when you can't generate energy, how you can generate electricity then? Electricity is form of energy, right? We convert, right? Thermal energy into electrical energy, hydro energy into electrical energy, right? Wind energy, solar energy, everything we convert. Like we convert. Conversion is the principle of life, right? You grow in life by eating organic and non-organic food. You convert the energy, right? In automobiles, we convert chemical energy into mechanical energy, and that's the reason we call it internal combustion vehicles, right? Now let's talk about the small ecosystem. So in electricity, the air where it's converted, transmission, distribution, and then it reaches the consumer, right? So we have 6 stakeholders, right? Now, if I want to define the ecosystem of automobiles or the petrol diesel cars that you have, how many stakeholders? 6. Okay. You have to help me with the answer. So first I've given OEM. OEM means the people who assemble the vehicle or the component manufacture R&D. They all go as a generic word OEM. What about other 5 stakeholders? You all can answer. Let's see. Yeah, go ahead. Yeah, you drive these cars, right? You know the ecosystem, right? You know, in Marwadi, it's always like that. Know the depth. It will increase the confidence. Okay, Lakshya said battery and components. We are talking about sir internal combustion engine. It has lead acid battery and component is manufactured by. So it comes in OEM. Excellent answer, sir. What about others? Okay, let me give you a drop a hint. Without this, you can't drive these vehicles. Yeah. Excellent, Prakash, sir. Fuel, right? So fuel has its own ecosystem, mining, refining, right? The third one, so it's the second one. Huh? Excellent. What about others? Hmm? Go ahead. Yeah, go ahead. Without this, you can't drive it. And in Gurgaon and Bangalore, you know, this is common. When it rains, you know, the development has reached such a vast level that during monsoon, rivers are coming to our houses, right? Yes or no? In Gurgaon and Bangalore, this is common, right? During monsoon, what happens? Rivers are coming to our houses, yes or no, to meet us? Road infrastructure, sir. So we have three stakeholders right now. So others are technically fuel, road infrastructure. Then we have the consumers, where we have sales, all those things coming in picture. Now let's change it to electric vehicle ecosystem. Who all will be there? What will change? Now I've made it easy for you. Meher ma'am, you can also answer, right? I hope you are doing good in electric vehicles, huh? Even Raksha? Yeah. What will change, guys? Because after this, there will be the first time you will understand what is electric vehicle and you will start differentiating it technically also. So if we can have quick answers. Okay. Technically, fuel is a chemical component, right? We have electric vehicles, they require electric charge. So the charging infrastructure is there. And then a change in standard and protocols because they technically keep the technology global. Now comes the biggest question of this whole session is what is a electric vehicle? Yeah. What is an electric vehicle? Hmm? What is a electric vehicle? Before that, what is electricity? You all know. But do you know when electricity came to India? So you have four options. I've made it simple. 4 years, 1874, 1907, 1857, 1879. Which year electricity came to India? Yeah. Now this is an interesting thing. Huh? Which year electricity came to India? Okay, 1873, 1879. Good one, Tarun sir. Good one, Prakash sir. Okay, Lakshya sir. Excellent.
Just a second, I'd like to interrupt Lalit. Your question, options, everything is not visible because of your screen on screen presence. If you could
Okay,
just share with, once again, share your screen without your screen on screen presence
okay,
in the
I'll do
normal
that.
mode, we will see everything,
I'll do that.
as we discussed.
Okay. Okay, it's visible now?
It is superb.
Excellent. Yeah.
Though we will miss you on the screen.
No. Yeah. Okay, the right answer is 1879, but you know in which city it came? Yeah. You know, before going into history. Oh, Mumbai. Excellent, huh? Excellent answer, Raksha. It's Kolkata. And how many of you know that how the name Kolkata came to existence? Yes, Smriti. So if you want to say something is fresh, it's a farm fresh. What do you say? Kal hi kata hai, right? So technically, what happened? The Britishers technically came to India. Everyone knows where they came. So they wanted grass for their horses, right? And how you say the grass is fresh? So these Bengalis say, Kal hi kata hai. And that's how the city got its name, Kolkata. Now, do you know what is an electric vehicle? Huh? Now, this is the most interesting thing. You know, electricity when it came to India. Now, let's talk about electric vehicle. So first, what is an electric vehicle? And when I say everyone, even your parents have traveled in an electric vehicle. Automation, everything works on the principle of conversion, right? So which is the core component which is used in an electric vehicle? And this will change everything for you from now on onwards. I'm really serious about it. Excellent, Sushi. You know, these are over your screens when we say these are electric vehicles. Am I wrong? Now let's first see. Am I wrong? Am I wrong or right? Are these electric vehicles, yes or no? Just understand, you know, technology in physics, definition is definition, right? And the definition says any vehicle operating or propelling on motor is a electric vehicle, right? You know, that's how the physics is. So the concept remains concept. Electric vehicles are there. And when they came to India, so I'm giving you 4 options, right? So this was the first electric vehicle which traveled in India. Okay. Now you have to guess. So we don't cut any marks for guessing, huh? So everyone is free to guess. Let's see. Excellent. Yeah. 1912. Okay. Excellent. Yeah, it is in Mumbai. That's true. It's in Mumbai. 1925. Huh? Someone has gone through Google, right? Yes? Okay. Now, what is the limitation of these vehicles? How many of you can own them? I hope a lot, right? The challenge is because they require continuous supply of electricity, right? If you see the fridge in our house, AC in our house, we are giving continuous supply of electricity through connecting them to electric source. So here, to give the electricity, we have to create an infrastructure, and that's costly. So that's the reason everywhere in the world, government own these vehicles, right? We can't own them. So to surpass this limitation, what you can do? Yeah, what you can do? If you replace continuous power supply with portable power supply. Hmm. Can you do it? We have done it telecommunication. Remember, till 2020, we had the phones with wired lines. After that, what we did? We powered those phones with battery, and today we have mobile phones, right? So portable power source, right? So that's how comes battery electric vehicle. So how many types of electric vehicles are there? Let's have a look. We will discuss about that. But this was the first battery electric vehicle which came to India, and the year was 1993. Which year? And the name, the beauty is the name. It was called Love Bird. Okay. And no automobile company brought it. It was technically brought by Eddy Electric with Yusaka, which was a German manufacturing company. Okay. Oh, sorry, Japanese manufacturing company. And it was the dream project of that time uh, Prime Minister of India, Rajiv Gandhi. Got it? Now, this was the first electric vehicle. This is a battery electric vehicle. Remember, we are not talking about electric vehicle. Can anyone guess which year it was? The image looks like fantastic, right? Thanks to the high definition technology. Can anyone guess me which is the year? Now, this is the first battery electric vehicle running. Yeah, excellent. I have not given options, huh? Just an eye opener. Okay, how much old is electric vehicle technology? Without option. It's 100 years or 200 years or 300. Prakash, you are right somewhere. It's somewhere 200 years back. So what they did was, okay, so this was the year 1832. Just if you remove 6 years, it's like 200 years, right? So Robert Anderson technically removed the horses from the horse cart, put a battery, put a motor. It became a it became a battery electric vehicle. Okay. To your surprise, that time we were having battery electric vehicle. Okay. And this is officially a battery electric vehicle, which was used by Queen Elizabeth, the Queen of France, right? And you know what was the waiting period that time? Just 38 months to buy a car. How much? 38 months. So Mr. Anas Jadlik invented the electric first, then came the first official public electric vehicle, which was in 1884. Now these cars were technically there, right? Now, the most amazing thing in this image, What the girl is doing? Can anyone tell me? The vehicle is made by Thomas Alva Edison's company. You know Thomas Alva Edison, the inventor of bulb. His company was making this car, okay? And this was a super model that time. What she is doing, this is the advertisement of a battery electric vehicle. She is charging the car. This is a lead acid charging machine, okay? And which year it was? It was 1912, okay? So in 1907, Thomas Alva Edison established a company and they were technically selling 13,000 units. How much? So technically what happened? We ditched them and now we are back. Yeah. So in 1997, something changed. We got the first hybrid electric vehicle, official electric powertrain coming to automobiles in the year 1997 by Japan. And this car changed today everything. And remember, this car company started in 2008. Okay. And the valuation of the second image car company is equal to all the companies combined together, working from last 150 years. You know the name, right? And it changed everything. And the name is, excellent, huh? Just excellent. Okay. Tesla, right? They changed everything. Okay. So why we are moving to battery electric vehicle and why it's a future? Because a lot of challenges will come to your mind. Now let's take a simple thing. Okay. Why electric vehicle, according to you, has making a comeback? Because some myths must be clear. A lot of myths are gone, right? Technically, you say electric vehicle, but it is a battery electric vehicle. We'll discuss that. And whatever the trainings we do in battery electric vehicle or a hybrid electric vehicle, right? Electric vehicle is not our domain. Yes or no? But we will say electric vehicle, right? So go ahead and tell me why we think that battery electric vehicle is the future, and then I will answer it. Thank you. Ajay. Recharge. Okay. Ashutosh. Excellent. Portable. Okay. Lesser cost. Okay. Okay. Let's see. How many of you think environment, sustainability? Let me tell you, my friend, any one of us has done something for environment or sustainability? No, right? Do you know someone who's doing it? No. So this is a market gym cake, right? So we are not going deep there. Let's see the understand it. Today, right now, we have more than 832 vehicles on road, millions, right? The consumption of fuel is on a higher side. So what we want to do is we want to address that increasing demand by creating alternative technologies, right? So battery electric vehicle is a choice, and then we have hydrogen fuel cell vehicle. Okay. Now understand in a different way that we want to reduce the fossil fuel mass deployment, right? With renewable energy, because electricity can be generated through renewable energy and fossil fuels can't, right? And second is efficiency. Okay. And that's the reason. And the third and the most important reason is America. Why America? So there is something called CAFE norms. So America was making cars, the OEMs where they are making huge, big engine cars. So they were making a lot of emissions. So America brought CAFE norms. That means you have to limit the emission of your fleet production. Okay. Now what happened when America makes a rule? It's only for America or it's for the world? So all the world is copying it. CAFE norm says that you have to manage your fleet. So company don't have an option and they have to go either hybrid or either battery electric vehicle. And that's the biggest motivation. Okay. So battery electric vehicle is here to stay for next 2 centuries. After that, I don't know. Right? How many types of electric vehicles? So let's give it a quick understanding. We have technically 4 types of electric vehicles. One is pure battery electric vehicle, one is hybrid electric vehicle. Then we have fuel cell electric vehicles, the hydrogen technology, right? Today, after half an hour, you are clear with the technology. You will be telling people, huh? And then we have plug-in hybrids, okay? And a bonus. How many of you think a car can be driven by solar energy? Just raise your hand or message in the chat. I will explain it. And if you don't believe it, I will skip it, right? So how many want to know that a car can be driven by solar energy? And if you want to know, let's see. Okay. Okay. Excellent. So that's a bonus for you. Now let's talk about the first foremost battery electric vehicle. So let's first start with the concept, right? So battery electric vehicle is a type of electric vehicle where we use portable batteries to share the electrical current with motor so that the vehicle can propel. And when we talk about the concept, this is the concept. So initially what you have a battery. You have a battery, okay? Now this battery has current, right? And you have a motor. When you give current, connect battery directly to the motor, a constant current will go from battery to the motor. But in automobiles, what we need? Accelerate and deaccelerate. So we have to control that current, and that's the reason we have controllers. In a very simple understanding, how many of you can drive a vehicle without brakes? It's easy, right? Every one of you can drive a vehicle without brakes. Prakash sir, you have raised your hand. I can accept that you can drive a vehicle without brakes. Okay, the brake is the reason that we can accelerate, right? So that's the thing, right? Now let's understand what are the new age battery electric vehicles, and this video will technically help you understand where we are and what we are going to do. So I'm sharing this video with you. So this is a battery electric vehicle from Mercedes. Okay. So battery electric vehicles have electric powertrains, and the core component is motor, which is there right now. So this motor is powered by the battery pack, which is there. If you see, there's a cooling mechanism to it to control the temperatures, because when you technically use electricity, a lot of energy is generated, right? And that energy, a lot of heat is generated, right? So we have a cooling mechanism. Okay, this cooling mechanism to control the electric powertrain as well as the battery of these electric vehicles. So these vehicles today, we have reached a big level of maturity, right? So not only they are designed like this, even the battery which is placed there is placed in such a way that increases the gravity of the vehicle, right? So this electric powertrain, it has two motors. One is the front wheel drive, one is the back wheel drive. Combined together becomes all wheel drive. And the best part is that you drive and you generate electricity also. So there's a feature called coasting, right? So when you do coasting, you can see around the vehicle is generating energy. So regenerative braking as well as coasting helps you uh, recoup that energy and save it to charge the batteries, right? So even a loss of energy is harnessed. Then you can these vehicles come with different cooling and heating mechanism, right? And as well as you can also uh, select from different modes, right? So these are battery electric vehicles today, aged battery electric vehicles coming with the most advanced technologies, right? Even if you see, to drive, you have acceleration 10 times more than your internal combustion engine, right? So these battery electric vehicles have aged technologies, right? The third thing is that if you see the batteries here, so the batteries which are there is placed in the center of this whole ecosystem. So it increases the gravity. That means a better ground clearance to you, right? And these batteries, if you see, there are 384 cells, all are prismatic as of now. So we'll talk about them later. And this is the cooling pipes, and then they are connected with the vehicle system, right? So this is how the battery electric vehicle. So battery powertrain as motor, and we have today advanced features which technically used connected features for these vehicles, right? Now let's talk about the components. So it has battery. To manage that battery, it has a battery management system. Charge port, because the battery requires current, right? In charging, we'll understand what is charging today. Okay. There are contactors for the safety, motor to propel the vehicle, motor controller. Okay, how you convert AC to DC? Every one of you, we have a battery at home, right? So when the electricity is there, the battery is charged. So technically convert AC into DC. When the electricity is not there, what will happen? The battery is used to give you energy, right? But which component does that? Which component does the conversion? It's the inverter, right? So at your home, have you ever wondered, the electricity supplies 230 volt, the battery's charge is 12 volt. So how that 12-volt battery technically addresses the gap of 230 volts? No problem, we'll discuss that. And how your technically mobile charges a 5-volt battery. Hmm? That's all coming to you. So let's start with a hybrid electric vehicle. So you all have eaten hybrid tomatoes, right? Yes or no? Hybrid tomatoes. Huh? What's the difference between a tomato and a hybrid tomato? Hmm? Is there a difference? Hmm? Bit, right? Not more, right? Let's talk about hybrid electric vehicle. So hybrid electric vehicle technically has two powertrains. Okay. Hybrid electric vehicles has two powertrains. That means electric powertrain, which is a special one. So it takes energy from the battery, goes to the motor, propels the vehicle, right? Second is the internal combustion engine, which converts electrical energy to mechanical energy to propel the vehicle, right? So when we say hybrid, it has two powertrains. You can see internal combustion engine as well as electric powertrain. Okay, with a lithium ion battery to it. With a lithium ion battery to it. Okay, but now if you see, when you start your vehicle, you know, there is a starter generator or alternator. So technically that's a motor only. Okay. The battery of these hybrid electric vehicle has a very unique thing. Yeah, it's very unique. Can be made mostly of lithium ion cells only. Today you will understand what lithium ion cells are. So this is a hybrid electric vehicle and the battery I said is very unique. Why? Because these batteries are charged only by the engine. You can't do any home charging to it. Maybe AC, maybe DC, you can't do any sort of charging. What I want to do is the engine charges the battery. Now let's understand the working principle. Now that's a very interesting thing. Huh? So the vehicle will start, right? So engine needs cranking, right? So your vehicle alternator does that when you start the vehicle. Here you have electric powertrain. So a motor with electric powertrain. So remember, every time when the vehicle will start, it will start on electric powertrain. Point number one. Point number two, electric powertrain is 1/10 of internal combustion engine, right? To make the vehicle stability more, right? Now these have a principle of working. If you see hybrid, you can't drive the vehicle at 100 km per hour. Different OEMs have set the limit of maximum range you can go 3 kilometers, maximum speed 20 kilometers. Now let's take Toyota as example. Here, you are driving the vehicle. Initially, the vehicle started at electric powertrain. You cross 3 kilometers of range or move above 20 kilometers of speed, or the battery goes down. What will happen? The engine will take over. Now you can see engine is propelling the vehicle as well as charging the battery. And when you require more power, you can combine both. You know, and what is regenerative braking? We are not talking about motors today, but reverse of motor is generator. As simple as that. Okay. So regenerative braking technically helps you console the lost energy into electrical energy. Okay. So enhancing your energy while driving. Right. So that's hybrid for you. Okay. It reduces the emission and it address all the challenges that you have with battery electric vehicle. Okay. Any questions here? Then hybrid. Then we'll move to plug-in hybrid. Right. Right. Excellent. Now let's talk about the second component. What we say is fuels. In hybrid, you have three different levels, right? So micro hybrid. Have you ever heard the term micro hybrid? So let me tell you, today we have starter generators which technically aid the vehicle start and stop. So reduce the emission by less, tell 10% of it. And have you heard the term SHVS? Smart hybrid by Maruti, smart hybrid by Toyota, or smart hybrid by Mahindra. So technically, there you have a starter motor which technically supports the vehicle with engine start and stop. Then regenerative energy as well as boost, because motor always have a better torque compared to engine. So when you use motor torque and align with the engine torque, you get a better torque, or we say refined torque. And finally, the full hybrid vehicle where you drive the vehicle, regenerative braking, start and stop of engine. Okay, so it will take you understand that why in hybrid electric vehicle it will only start on electric. The second is plug-in hybrid. Now here I said in a very simple words that you have a lesser battery, right? Can be charged by engine. But if you increase the size of the battery and you charge by engine, there will be more of a effort issue with the engine, right? So engine power down will go down, right? So we do plug-in hybrid. If you increase the size of the battery, increase the size of the powertrain equal to the electric internal combustion engine. So what you want to do is, right? You want to charge these batteries from external power source, and these are called plug-in hybrids. So when we say plug-in hybrid, if you see, they are just like hybrid, but the difference is they are costly. Huh? Why? They are costly because the battery size they have is equivalent to a battery electric vehicle. So this is Kia plug-in hybrid, has 20 kilowatt of battery pack. The previous car was having a 5 kilowatt of battery pack, right? So that means if you can drive on hybrid, say 5 kilometers, in plug-in hybrid, you can drive for 50 kilometers. In plug-in hybrid, you had a limitation of going to, you had a limitation of going to 50 kilometers and a top speed 20. Here you can go to 50 kilometers and you can drive at 100 kilometers per hour, right? So it's more of a battery electric vehicle coming with an engine which supports you during the breakdown. Rest everything remains same. These vehicles behave more of a battery electric vehicle than a internal combustion vehicle. Here engine will only come in picture when the battery goes down, right? Or you need torque assist, right? So it behaves more of a battery electric vehicle compared to hybrids. And that's the reason we call them plug-in hybrids. Now here you can see the battery has gone down. Engine is propelling the vehicle as well as charging the battery, right? So that's plug-in hybrid for you. And you can charge these vehicles from 15 ampere sockets that you have at your home. Do you know 15 ampere sockets? You put that air conditioning system and the refrigerations, right? So you can charge by that, as simple as that. Or you can do public charging as well. Now let's move toward energy, which is 100% pure and clean. Let's talk about fuel cell. You have heard about hydrogen vehicles? Yes or no? A lot of hype. And one of the ministers in India is driving that. You know that? Yeah, the person who always says something, huh? Road minister. Now, hydrogen. Hydrogen is ready available everywhere. Yes or no? Plenty of hydrogen, but not in the pure form. Where you find pure form of hydrogen? Sun, right? If you have pure hydrogen Earth, what will happen? The temperature will be somewhere 17,000 degrees, right? A challenge? No. So hydrogen is highly flammable. That's the reason it's not available in the purest form. But H2O is hydrogen plus oxygen. Now this energy is the cleanest energy on road. Let's see it, then believe it. Should I go ahead? No answer. Guys, should I go ahead or should I skip?
Please show emojis, react, thumbs up.
Okay, let's talk about these technologies. Yeah. So this is fuel cell electric vehicle or called hydrogen fuel cell vehicle. Okay. The technology is excellent. Hydrogen plus oxygen equals to water. So you store hydrogen in these tanks, lithium-ion battery, fuel cell stack, and motors. So this vehicle technically takes hydrogen from the cylinders and oxygen from the atmosphere. converts it into electricity, and you see the exhaust is water. When exhaust is water, so technically it's 100% clean energy, no emission whatsoever. And for hydrogen, you can do electrolysis, right? You put current in water and hydrogen liberates. So you can create hydrogen anytime, anywhere. Now you store hydrogen in this cars. As I said, this is a hybrid electric vehicle. It's a hybrid electric vehicle. You'll see this hybrid electric vehicle works on electric powertrain, starts on electric powertrain. Then it has regenerative energy, right? Now, over the time, what will happen? As in hybrids, the battery power goes down, the fuel cell stack will come in picture. Now, this fuel cell stack, if you see, okay, now when you see this fuel cell stack, what happens? This fuel cell stack creates electricity to propel the vehicle as well as charge the batteries, right? This fuel cell stack is creating energy, which is charging the vehicle as well as battery. Are if you have high load driving, you can use the motor. Two motors, one is the electric and one is this fuel cell stack one, combined together create better torque to propel the vehicle at inclines. So no energy loss, right? Now how this fuel cell stack technically works? Amazing, huh? So one side, there is hydrogen. So let's open a cell. These cells have number of cells. You can combine in series and parallel to get the current and voltage output. You can see the blue is hydrogen. You take that one electron from that hydrogen by passing it through anode, which is a negative element. Now use that one electron of hydrogen, but can you liberate hydrogen in atmosphere? No. So this hydrogen in the atmosphere is highly flammable, right? So what you do, you add oxygen to it. And when hydrogen and oxygen combines, what it becomes? The prime source of life, water, right? So that's the reason we say hydrogen is 100% clean technology. 100% clean technology. Now let's talk about the most amazing thing what we are looking for is solar electric vehicle. Huh? Yeah, solar electric vehicle. Let's see what it is. So this solar electric vehicle, when you say, is a normal vehicle just like our vehicles. The difference is in the frame. So right now this vehicle uses 330 cells which are solar. And we all know the efficiency of solar panels is 15%. So this car can self-charge for 30 kilometers a day range. With a total battery of 50 kilowatt, this car can be charged 7 days continuously in the sun for 8 hours. Okay. In one day, it can charge for 30 kilometers. That means you can do one side of trip, right? And you can charge the battery with external power source. You can use the battery of the same car to charge other car also. It's called vehicle to vehicle charging. Okay. And these cars come with a different set of eco sustainability things, just like organic support system or warmth control system, right? Because where it's been made in Germany, their temperature is cooler side, right? So that's the reason they have. Here we will be having the gel technology to keep the car cool. Okay. So this car is commercial viable. It's called Sion and it's ready available in Germany to purchase. Okay. And they only are not making cars, they are making planes, they are making ships, right? Everything is ready available for market. Now let's move to the lithium part. Now let's move to the lithium part. Okay. What is lithium? What is lithium? Hmm? You can see on the screen, this is the purest form of lithium. 92% pure lithium. How it looks? Just like silver, right? But what you know about lithium? What do you know about lithium? Yeah. Hmm? Lithium is the most reactive element. Hydrogen is the most reactive gas. Okay. And how much reactive lithium is? Now, I'm using kerosene oil to keep lithium. Lithium is very soft. If it's the purity increase the softness, right? So technically, you can cut it without a sharp edge device. But if you keep pure lithium in the room, what will happen? It will start reacting with the room nitrogen. And after 2 hours, you come, there is black powder. Where is lithium? Gone in the air. Gone in the air. So that's the reason I keep lithium always in kerosene oil. Okay. Now, when there is a fire, what you do? Put water. But when there is a fire in lithium, you put water, what will happen? It will release hydrogen. And hydrogen is flammable. That means if you put water on a lithium fire, you increase the fire instead of decreasing, you increase the fire. And the best cracker is Ola, right? For Diwali. So your mobile phone battery, don't do it this at home. I've done it for you. We use the iodine water and we put a battery pack to it and see. It makes a very good sound. Believe me. The whole society will know that you are running Diwali like anything. Huh? Second thing, lithium works as a catalyst. Lithium evaporates at 60 degrees Celsius. It does not melt, evaporates. The melting temperature is somewhere lesser than that, right? But the amazing thing is that it will decrease the temperature of any thing. So we are trying to burn lithium here. You can see it's burning the metal, which is the furnace. It's burning the stand. It's burning aluminum, copper, tin together. So it can decrease the melting temperature of other components. And that's the best thing about lithium fires, right? So when an automobile gets lithium fire, you don't have anything for forensic test, right? And at 2000 degrees, your sand becomes glass. But if you put lithium with it in 3.3 minutes, what will happen? What will happen? It will make a glass out of it. Got it? So that much reactive is lithium. So don't try, I've done it for you. Okay. But do we have enough lithium globally? Do we have enough lithium globally? Hmm? Do we have enough lithium globally? Yeah. We all have this question that lithium is in the scarcity, right? Right? Yes or no? Do we have enough lithium? Yes, we have enough lithium. Lithium is the most abundant metal on earth. If 830 people are given a car with a battery of 60 kilowatt, you don't require to refurbish it. You don't require to refurbish it. Got it? So lithium was discovered in the year 1971. The first cell was made in the year 1991 by Akira Ishino. He got the Nobel Prize later in 2019. Tesla launched the first car in 2008. So lithium is available in two different forms, right? One is in the brine form as a liquid inside the earth crust. Second is in the form of hard rocks above the earth. So we technically mine it, right? So right now, if you see here in this image, what we are doing, we are pumping the brine, which is inside the earth crust. The brine that we are pumping from the earth crust by drilling the earth, we bring it out, put it in the front of sun. Then we technically increase the temperature. So sun radiation technically increase the temperature. And over the time, we reduce the humidity or the moisture content, take the lithium carbonate out, and then let the solution go inside, the brine go back. Technically, this is how it's done. Now, these are the bigger mines. If you see, this is Chile. Okay. This white powder all is white gold, or we can say lithium carbonate. Because lithium is 100% reactive, so lithium is not refined more than 6 to 7%. So what they did, they pumped and brought this brine. Now this brine is 3000 degrees Celsius hot. Okay. So we bring it out, put in the beds. You can see these beds, different beds have different colors. So it starts from green yeah, and goes to yellow sludge, right? So technically we change once that color changes and a lot of water is used here. So now this crystallized form of lithium is taken over. Then it's sent for refinement wherever you want to make the cells. Because the transportation of an unrefined thing is more convenient, more easy, and more safe. Okay. Then let's talk about the second form, the rock extraction. So we will not go deep here. So technically here what we do is we initially bring the salt rocks, then we technically break the rocks into smaller particles, maybe 2 mm or less than 2 mm. Then we wash those particles. So here you see we are using first a rolling machine. Okay. Now in this rolling machine, we are putting the rock, powder, then further refining it through a hammer mill and reducing the size to 2 millimeters because we have to remove lithium carbonate. We have to remove lithium carbonate. So when we get it, then we wash it thoroughly with water so we can remove the impurities and the scent. So when washed with pure water, impurity removed, what we will do, we will add different agents to it so that we can further remove further impurities. So spodumene and dolomite are two agents that are technically added to it in this ball mill. Now we will technically first heat this arrangement, make granules out of it, and then we will heat those granules so that we can technically remove the carbonate part of it. So now they are technically going through a king. So we are removing the moisture. Now they are technically like crystals. Then these crystals will be further going through a clink. Again, we are technically removing all the moisture which is there. Now they are becoming more of marbles. Then we will technically cool them down. Okay. And now we have three different components. Okay. Further, we will use three different agents, calcium, magnesium, mix it so that we can technically create lithium carbonate. We can create lithium carbonate. And lithium carbonate is what we are looking for, right? Because lithium carbonate can be transported. A better lithium can't be transported because lithium is highly reactive. Yes or no? Right. So now you have available powder. You will first recreate the in the crystal form so that you only have the carbonate part because and then you pack it down and it's ready for distribution. Okay. Okay. So that's how technically you get the lithium. So we have lithium in India, right? We all have gone through the news, lithium in India, right? How many have gone through that news? There is a lithium in India. Yeah. Sushil, huh? What about others? When we have lithium in India, then why we are not using that lithium? Yeah. We have lithium in India, right? Then why we can't use it? Hmm. There's ample lithium in India. That's right. The second thing is to understand the lithium is in Rajasthan, J&K. These all are in the form of heteroclay. Okay. Or they are combined with clay. And we don't have any process, mechanical process through which we can extract this lithium, right? So that's the reason we are not able to consume it, but we will be having this lithium in the future. Now, what is the biggest challenge that we see is coming from lithium? Lithium is creating fire, but why it's creating fire? To understand, let's understand how a lithium ion cell is made. So we know lithium is highly reactive. Now to reduce the reactivity of lithium, what we do is we add different metal oxides to it, right? So what we are doing is we are technically using different metal oxides to it. Okay. So here what we are doing is, okay. So this is technically a part where you have copper at anode. So we have using graphite at anode, copper and anode. So this is something in secondary cells, we use the positive element at anode. At cathode, what we do is we are having lithium along with different metals. Like you have heard NMC cell, LFP cell, NCA cell. Now what it is? They all are the part of the different metals that we use to make cathode with lithium. So because we are adding different materials, we have different properties of these cells. Okay. Now technically how a lithium ion cell works is we create a cathode to reduce the reactivity of lithium. The electrolyte is made of lithium. Okay. Electrolyte is made of lithium. So when you charge, what will happen? The lithium will move from the electrolyte and the electrons will move from the power source. You can see in this. So at cathode, anode, the lithium and its electrons are there with a bond. That's the reason lithium ion cell phone does not discharge, right? You manufacture it today. After 2 years, you open the phone and boom, it's working. Yes or no? Right? So lithium charge is a stable thing, and when it discharge again, it will move from the electrolyte. Now, if the temperature goes beyond 60 degrees Celsius, how much of this cell? The electrolyte will evaporate and the lithium will move freely. Electrons will move freely. When electrons move freely, what will happen? Boom. Uncontrolled energy, it's a bomb. So technically, don't take the temperature beyond 60 degrees, right? You have electricity, you're using electricity for your life. But do you ever touch a naked wire? No. The same thing. To use lithium, only thing is understand the temperature above 50 degrees Celsius, electrolyte goes away, and then there is an uncontrolled energy because of the movement of electrons. They collide, and because of that, the cell bursts. Okay. Now, when you see if second thing is when you we all know that lithium can give you fast charge, right? Yes or no? How? Yes, understand. You increase the current, so more lithium will move, more current will move, more electrons will move, right? So you can increase the current to a certain extent. You can charge it fast, discharge it fast, right? So that's about lithium ion cell, right? So working, we have discussed how they work, how we are made. There are different chemistries, like we have LFP, NMC, LMO, NCA. If you see cathode is different, anode is same, all made of. Yeah, Smriti, you have to say something.
Smriti, do you wish to say something? If then you could put it in the chat box.
Okay. So technically, if you see here, anode is made of the same element, but because of a different element at cathode, you have different safety. Now this is thermal safety, right? At 60 degrees Celsius. So LFP can go up to 80, 85, right? So it's good for India. NMC is good for Canada and US because that's very cold, right? Power density means in a how much fast it can charge and discharge, like capacitors. So NCA is the best. That's the reason Tesla was using NCA. Energy density, when we say in a given area, how much energy it can store. So maximum energy can be stored by the NCA, the nickel and cobalt salt, right? Then you have the cell cost. So right now the NCA has a very huge production, mass production. And when you have a mass production, the cost goes up or comes down. If you talk about the lifetime, LFP is a very good cell, then NCA, then titanium. And battery energy, again, you will find that LFP and titanium are very good, right? So that's a different chemistries. Now, how you charge these cells becomes an interesting thing. Huh? So what is charging? We all do charging, right? Now, can anyone tell me what is charging? Huh? What is charging? Hmm? You all do mobile charge, laptop charge. Just understand, it's very simple. The available current is AC, alternating current. If you see the current which is coming to your home or office is alternating. To charge, you convert AC into DC because the DC current can be stored. AC current can't be stored. So charging in a nutshell is a process convert AC into DC, right? Now the most amazing thing is how many charging technologies are there? Now this is a very interesting thing, technologies. Because this word is very interesting in itself. Yeah. You have four: conductive charging, inductive charging, mechanical and flash. I hope no one you have ever heard these terms, right? These are technical terms, not layman terms. Now see what layman terms is. In conductive charging, technically you connect the vehicle to the charger manually. And in this you have AC and DC. Now what is AC charging and what is DC charging? Go through this image, you will understand. Now this was my intern days from Tesla, so I've taken it from there. Okay. Do you see a difference? Yeah, there is a difference, right? When the small charger is there, onboard charger comes in picture. When the bigger charger is there, onboard charger is not in the picture. Right? Every one of you observe the same thing. This is why the vehicle has an onboard charger. So when you feed alternating current to the vehicle, someone has to convert it into DC, right? So that the current can be stored in the form of DC inside the battery packs. So you have an onboard charger. Now this onboard charger is 3.3 kilowatt, right? You can increase the size of this onboard charger. You can make it 7, 10. Today company we are doing it because initially the battery was 10 to 20 kilowatts. 3.3 was enough. Now it's 60 kilowatt. You are using 7 kilowatt. We can make 20 kilowatt, 40 kilowatt, right? Not a challenge. What an onboard charger is doing, converting AC into DC inside the vehicle, right? Now let's do one thing. Instead of increasing the size of onboard charger, let's increase the size outside. Because if you increase inside the vehicle weight, vehicle size will increase, which will technically impact the vehicle range. So what you do now, you convert AC into DC outside the vehicle. Now you directly feed the DC current to the battery. So you have surpassed the limit of AC current. Yes or no? That's the reason we call DC as fast charging, ACS, right? So technically in India, we have three modes. One is the AC level 1, where you technically charge your vehicle with a 15 ampere socket at your home. So one side is a vehicle gun. AC type 2 is a dedicated connection. Now, a lot of you don't know how much electricity is coming to your home, right? Because in India, we have sanitization for hot water, but no sanitization for electricity. Because our parents never understood an electric vehicle is there to come. Huh? Yes or no? Anyway, let's come back. So 15 volts into 15 amperes into 230 volts is 3.3 kilowatt in a very nutshell. And that 3.3 kilowatt is not free. A fan is running, a laptop is running, a AC is running. And you are using the same current for vehicle charging. So maximum output is 1 kilowatt. Today, Tata Nexon comes with 30 kilowatt, right? You are charging the car with 1 kilowatt. How much time it will take? Just 32 hours. Yeah. So that's the reason today, if you buy these cars, you get a special chargers. And you call the discom where you pay the bill. They will come down to your home, install a special connection. Remember, whenever you need a connection for charging, discom where you pay the bill of electricity, because in India we have number of discoms, or you can go to fame 2 where they can know how to get the connection. They will step a connection at your home, and maximum connection in India provided at home is 15 kilowatt. So till 10 kilowatts you can have the charger. Now this is a dedicated charger. 7 kilowatt of output, 30 kilowatt of battery. How much time it takes? 4 hours, 5 hours. And that's good for you because you sleep 5 hours, right? Then comes DC fast. So DC fast can give you 20 kilowatt of charge, 30 kilowatt, 40 kilowatt, 50 kilowatt, depending on the capacity of your vehicle battery. And if you see, there are different connectors to it. So AC has Chadim, Yazaki, the type 1. If you see, manganese type 2. Then GB by T, which is a Chinese one. Globally, India takes type 2. Okay. Worldwide is type 2. Now this man is doing a AC charge of his car and see how simple plug and play it is. So technically what he's doing, he is connecting. Now this is a gun of AC charger, manganese one. He's connecting that to the charge inlet. Okay. Just watch the vehicle dashboard. Seeing a light there? That's a handshake. Whenever you connect a AC charger or a DC charger inside the vehicle, the current does not pass at the starting. There's a handshake happening called proximity pilot and protective pilot. So basically vehicle knows the charger is there, charger knows the vehicle is there. They both combine, share some communication, and then the vehicle charging process starts. 100% safe. Anyone can charge. There are no chance of electrical accidents. Have anyone of you have heard that someone died because of charging the car? 100% agile technology. Even you use 50 kilowatt, 100 kilowatt, nothing is going to happen. Okay. Second is, what is the capacity of the vehicle battery to be charged? Right. So the second one is a DC charger. This is the AC charger, which I'm showing right now. Okay. In DC, again, you have 4 technologies: combined charge system, CHAdeMO, Tesla, and GB by T, which is a Chinese technology. So technically in India, we are using CCS2, combined charge system 2. You can see the CCS2 and CCS1. So we'll talk about that. CHAdeMO is a Japanese technology, Tesla is a proprietary technology, and GB by T is a Korean and Japanese technology. So combined charge system, because you can charge the vehicle from the same inlet. That's the reason we call it CCS. And if you see over your screens, there's a difference. Is there a difference between CCS1 or CCS2? Now this is CCS1, right? You can see 5 pin for AC charge here. In CCS2, you have 7 pins for AC charge. For DC charge, you have 2 DC pins in CCS1, 2 DC pins in CCS2. Technically, nothing has changed. What has changed over the years? Previously, the batteries were coming small, so we were using single phase charging technology. Today, the batteries are bigger, so we are using 3 phase. In DC, nothing changed, right? So that's a technical difference between AC and DC charge here. Okay. So let's see. So that's the reason we call it combined charge system. And if you see here, the CCS1 and the CCS2 connector is different at the AC side, not the DC side. Okay. Not the DC side. Correct? Now, can you charge your car wirelessly without connecting the wire? Can you charge the car batteries? Yeah, we can do. It's called inductive charging. Remember, the first was conductive, second is inductive, where you don't require to connect the vehicle to the charger. It's called inductive, wireless. If you see in this, BMW was the first company to invent wireless charging technology called inductive. Okay, it works on the principle of induction. That's the reason we call it inductive. Here, technically, what you have to do, you have to park your car over the charger. Okay, so we are doing it. So this transformer technically works on these technology. Even your induction chula works on those technologies, right? So right now he has parked the car over the charger. Now what will happen? A current will technically go inside the coil, the charger coil, and that will emit the current in the receiver coil, which is inside the vehicle. You can see the charger coil, and then there's a receiver coil inside the vehicle. That's accepting that current. Now this current is moving through the vehicle onboard charger because vehicle requires a DC Battery requires a DC current, yes or no? So here what's happening? This is converting it to DC and the battery is taking the DC current here and the battery is charging, right? So you don't require to connect the vehicle to the charger manually. You have something called wireless charging technologies. Okay. This is ready available in India. Brands like Mercedes and others use it. Then you have, so here technically what you do is you have a grid, convert first AC into DC. Why? Because at your home, the frequency is fixed, 50 hertz, right? You can't do anything. So we convert into DC, then we convert into AC to change the frequency. Then we have charging roads. You drive the car and the vehicle is charged. These roads are there in France as well as in German, right? So coils are beneath the road. You drive the vehicle. During the drive, vehicle gets charged. Even the pantograph charging is there, right? Now, can you reduce the charging time to less than 3 minutes or less than a minute? Range anxiety, right? What you'll do? We have a technology called battery swapping. So in battery swapping, technically what you do is we replace a discharge battery with a charge battery. This is called mechanical. So this driver will technically step down, go to the machine. First, he will communicate to the machine. Machine will open an inlet for him because that's a subscription based thing, right? That's a subscription based thing. You can see. Now this battery will go inside. The machine will calculate the same battery it has when it was given to this person last time. Okay. Once he checks, the machine will give him the charge battery. It's called battery swapping, right? As simple as that. Less than 3 minutes. Now these batteries are manually easy. The maximum weight they have is 10 to 15 kgs, right? Manually you can do it. What about car batteries having 400 kgs of weight? Can we do it? Yeah, we can do it. Today we have technology, man, right? We have lifts. So same thing happened with these cars. We technically lift the charge battery, replace it with a discharge battery with the help of robotics and hydraulics. So open the battery pack, replace the battery pack, as simple as that. Put the fixtures back and done. You are boom to go. So they open the vehicle frame, battery frame. This is a discharge battery on the hydraulics. Going to the to be replaced by a charge battery. You can see the charge in both the batteries is different, right? This battery is having just a single bar. This is having fully charged, right? Now it will go and fit in the vehicle and you will have a fully charged vehicle and within less than 5 minutes, right? This technology is coming in commercial vehicle as well as last mile delivery vehicles for two-wheelers, trucks and buses are using this technology here back in India.
It
Okay.
is, sorry, but it is that feasible? It
Yeah,
sounds like invasive.
it's not invasive. A car company called Neo has more than 3,500 battery swapping stations in the US and Europe. I'm not
Wow.
talking about China. Okay. So it's feasible. Now let's talk about the ultra fast charging. So here technically what will happen is, okay. Here technically what will happen is that we will give a 600 kilowatt of charge. How much? 600 kilowatt of a charge in 20 seconds. This is called, uh, now this arm will technically go inside 600 kilowatt of charge, flash charging. That means these vehicles will technically travel, city buses. Every station they go will get a charge for 20 seconds and they don't require charging for the whole day. Drive and charge, drive and charge. As simple as that. So the charging technology has come a long way, right? Now let's talk about the future vehicles, right? Connected vehicles. Because the vehicles that we have today, there is a limitation. If you have to update your vehicle, you have to replace your vehicle. But that has changed now. Just like your mobile phone gets updated over the time, these vehicles get updated. Second thing, you can know what the speed of the vehicle in front of you. Is there an objection coming in front of you? So a connected wheel, whole ecosystem has come up. Because The traffic is because of humans intelligence or human you know anxiety. So technically, this will help reduce the traffic, reduce the accidents, because we are moving to autonomous vehicles. We are moving to autonomous vehicles. If you see, a lot of sensors are used to drive the vehicle, and for the safety, a lot of technology like ADAS, like autonomous driving, has come into existence. Right. So Qualcomm is a vehicle technology, and vehicle to vehicle communication is there, where you know the speed of the front vehicle, right? You know the environment, traffic conditions, if there is an accident, right? So all these vehicles, because of IoT and internet, have become connected, right? So these vehicles are connected to everything, help to the cellular technology and the 5G technology. Today we have a lot of communication happening. A pedestrian moving in the down street and the vehicle going moving near, they both are communicating with each other because of this infrastructure environment. So pedestrian is alerted as well as driver is alerted, right? So there is reduced charge of accident, reduced charge of traffic jams, right? When we talk about the wireless charging technology, we have a different role to play. That means the vehicle is now communicating with everything. Smart trafficking system is there, right? So collisions are reduced, you know, managing the traffic lights. And today we are in an age where we don't need even humans to drive the vehicle. We have full self-driven vehicles. If you see metros, the Delhi metros technically are fully self-driven vehicles, but they have a fixed route. Now we have vehicles because they are full self-driven, so infrastructure is also it's playing its role to connect this vehicle, because the communication has to move outside from the vehicle to the infrastructure, and there we are using the technology, right? So if you see in this image, the vehicle is having the advanced internet, which is technically sharing the information of the vehicle through internet to cloud server, where the processing of information is done. Whole environment comes in picture. So data collection from sensors which are inside the vehicle, data transmission through internet, and data processing, because you know that data requires to be processed, right? When we say English, does computer understand English? They only understand machine language, right? So they will speak in machine language, right? So once this data is processed, decision is made based on different patterns and the previous data using artificial intelligence, because artificial intelligence is capable of doing the processing which we humans can't do it, right? And with the help of feedback loop, we are recreating the environment, recreating the decision process in such a way that we reduce and address the challenges on the route. So today we have vehicle to vehicle communication, vehicle to infrastructure, vehicle to pedestrian, vehicle to network, and vehicle to grid. Now this is very interesting. Huh? Till now you have understood that you can charge your vehicle from the grid power. But when the grid, okay, when the peak time is there, you can use your car to stabilize the grid. That means you can use the grid vehicle to charge your homes, charge your buildings, run electricity, because they work as an inverter, right? They have 40 kilowatt of battery. You use a 12-volt battery to charge your home for some hours if you use a 40 kilowatt of battery, right? And if you use 10 cars, 400 kilowatts, right? Telematics is a communication system through which you vehicle starts communicating with the system, and you will technically use in different safety mechanisms to share the information of the vehicle and also know the position and localization of the vehicle. 5G is a communication technology. Then we have two types of communication. One is DSRC, where vehicle to vehicle is communicating. You have seen the walkie-talkies. So two walkie-talkie set does not require any wire to communicate, right? They have an onboard unit in both, working on the principle of intranet. Same happens with the telematics, right? Cloud computing is technically helping the processing power of it. And CV2X is technically the communication system, cellular communication, right? So we use three different layers so that everything comes in, communicate, enhance the communication. And finally, we have this whole ecosystem running. And that's what future is going to be, right? 100% connected, just like us. Okay. So thanks for your time. We are now at the end of this course. Now you can go ahead with your questions. I'm there for you. Thank you.